In this example, we're going to be determining a circumference and an area of a circle. A circumference is similar to a perimeter around a polygon, except a circumference is the distance around a circle. All circles are similar. They all have a common value or a common factor, and that common value is pi. Also, we have a scientific calculator here. I have the TI-30 emulator here. All scientific calculators have common keys. The one key that we're particularly concerned with is this one right here. This is the pi key. We're going to be utilizing that. So the problem says, Amos wants to place a decorative bed of stone around his circular swimming pool. He would like the bed of stone to be 1 foot in width around the pool. His swimming pool has a diameter of 20 feet. So here's a little graphic here, maybe representing what it could look like. Maybe this is a top view looking down on his pool. The blue portion here would be his swimming pool, and this stony portion here would be the bed of stone that he wants to lay around the outside of his, around the perimeter of the circumference of his pool. So a couple of things I like to point out here. Diameter. We have a diameter of 20 feet. A diameter is the distance from one end of a circle to the other as it passes through the center. So I'm going to put a diameter in here. I'm going to mark the center like this. And the diameter would go right through it from end to end. And the problem says this is 20 feet. A radius is half the diameter. It goes from the center to the circle's edge. So the radius for the pool would be 10 feet. Also, it says there is a 1 foot in width, a bed of stone 1 foot in width around the pool. So that's around here. So we're talking about a width right here. That's a 1 foot width. So then I guess the diameter from the outside edge of the bed of stone to the other outside edge of the bed of stone would probably look something like this. So from here all the way to the outer edge of the other side, that's going to be 22 feet. We've got 1 foot here, 20 feet here, and then another foot here for 22 feet. So from the outer edge of the bed of stone, that's got a diameter of 22 feet. Thus, it will have a radius of 11 feet. So for A, it says determine the outer circumference of the bed of stone around the swimming pool. So a circumference, C, that's equal to 2 times pi times r. Now, since the radius is half the diameter, or the diameter is twice the radius, then 2 times r is equal to d. So this can also be written as pi times d. So if we want to know what the circumference is all the way around the outside edge of our stone here, then I have a diameter of 22 feet times pi. Now this is an exact answer. 22 pi is an exact answer. 22 pi feet. As an approximate answer, that's where we use our calculator. I'm going to type in 22 times pi, and that comes out to be approximately 69.12 feet. We're just going to round this to 2 decimals. That's plenty to get an understanding of what's going on. So it's around 69 feet all the way around the outside of the bed of stone. B then says determine the area of the bed of stone around the swimming pool. Now the area is just this ring around here of the stone. That's just this amount here that we're looking for. In order to find that area, we'll have to find the area of the entire circle size. So the equation for an area, A, that's equal to pi times r squared. So if the radius from one end of the edge of the stone here to the other end here is 11 feet. The radius is half the diameter. So this is going to be pi times 11 squared. 11 squared, that's 121. So the exact answer is 121 pi square feet. We're talking about area. Don't forget we have to label it as square feet. We can approximate that. That'll be 121 pi. And that comes out to be approximately 380.13 square feet. But that's the entire size of the circle. I just want this ring portion here, the red. So what I have to do is I have to find the area of the swimming pool and then subtract that from the area of the entire circle of the stone, and that'll give me what's left over, which would be this ring here. So we'll find the area of the swimming pool too. That's also pi r squared, except the diameter is 20 feet, thus a radius of 10. So this is going to be pi times 10 squared. 10 squared is 100, so it's 100 pi square feet. What is approximately? We'll type in 100 pi, and it's approximately 314.16 square feet. So in order to determine what it is for the red portion here, the ring out here, all I have to do is subtract the area of the pool from the total area of the circumference of the bed of stone, and it'll give me what's left over. So we'll do 380.13 minus 314.16, and you could certainly use your calculator here. 380.13 minus 314.16, and that comes out to be 65.97 square feet, or I think it's fair to say that this area right here will be just about 66 square feet.